In November 2018, the U.S. Department of Commerce circulated a draft export control framework built around what it called emerging and foundational technologies. Buried inside the document were references to gallium nitride semiconductors, advanced lithography interfaces, and high-bandwidth memory packaging. 3 phrases, easy to miss. At the time, Washington's working assumption was that China remained years away from competing meaningfully in any of them. So why does China now hold patent concentrations in all 3 sectors large enough that American companies increasingly license around Chinese intellectual property instead of through it? That question matters more than the headline number everyone keeps repeating. 5.5 million active patents sounds abstract. It sounds like trivia designed for government press releases and investor decks. Most people hear the number and mentally file it next to Olympic medal counts or steel output charts. Large, impressive, slightly detached from daily life. But patents are not medals. They are legal claims on future production. They decide who collects fees every time a component moves through a supply chain, every time a battery chemistry scales, every time a communication standard becomes unavoidable. And that is where the story changes shape. The common American reading of China's patent surge has been almost comforting. Quantity over quality, subsidized filings, provincial governments gaming metrics, thousands of weak registrations with little commercial value. There is truth inside that argument. China absolutely inflated portions of its patent system during the 2010s. Local governments paid firms cash incentives for filings. Universities pushed researchers toward volume. Some applications bordered on bureaucratic performance art. But the comforting part is the dangerous part. Because while critics focused on the low-end flood, something else happened underneath it. China concentrated patent ownership inside sectors directly tied to industrial throughput. Electric vehicle batteries, grid infrastructure, industrial robotics, power semiconductors, telecom standards, materials chemistry, not glamorous consumer apps, not social media features, factory technologies, which is a quiet way of saying something loud. The West spent 2 decades talking about innovation as if it lived primarily inside software. China treated innovation as something that happened when research labs, ports, refineries, machine tools, universities, and state banks moved in the same direction long enough to compound. Different model, different assumptions, different outcome. Look at CATL. In 2015, outside the battery industry, almost nobody in America cared about the company. By 2023, CATL controlled around 1/3 of global EV battery market share, while building patent walls around lithium iron phosphate chemistry refinement, fast charging systems, and thermal management architecture. That matters because batteries are no longer just car components. They are grid assets, military logistics assets, and industrial policy assets at the same time. One chemistry breakthrough can ripple through shipping costs, electricity prices, and defense procurement simultaneously. Huawei followed a similar pattern. American sanctions cut the company off from advanced chips in 2019 under the Entity List restrictions. Washington expected contraction. Instead, Huawei increased patent filings in optical networking, industrial AI systems, and 5th-generation telecom infrastructure. The sanctions were designed to slow technological velocity. Huawei responded by moving deeper into the stack. Washington called this escalation risk. Huawei called it quarterly planning. There is a tendency in American analysis to separate invention from manufacturing, as if one country invents while another assembles. That distinction made sense in the late 1990s, when supply chains looked stable and software margins looked infinite. It makes far less sense when the same country refining rare earth minerals also dominates battery processing, solar wafer manufacturing, commercial drone production, and power electronics scaling. Factories learn. That sentence sounds simple until you sit with it for a minute. Factories generate process knowledge. Process knowledge generates patentable refinements. Patentable refinements improve manufacturing efficiency. Efficiency expands scale. Scale generates more process knowledge. The loop feeds itself. Meanwhile, much of America's industrial base spent the 2000s optimizing for shareholder returns rather than production density. Cheaper labor abroad increased quarterly margins. Wall Street rewarded the shift. Entire supply chains hollowed out slowly enough that most consumers barely noticed. You could still buy the product, it just arrived on a different ship. Then the dependency became visible. Masks during COVID, Semiconductor shortages in 2021. Transformer shortages after energy demand surged. The missing layer was not invention. The missing layer was industrial memory, and patents sit directly on top of that memory. By 2023, according to the World Intellectual Property Organization and China's National Intellectual Property Administration, China accounted for roughly half the world's active patent filings in several advanced manufacturing sectors tied to electrification and industrial automation. Half. In practical terms, that means future companies building within those sectors increasingly build inside rules China helped write. The important part is not that China became innovative. The important part is that China became difficult to route around. And the mechanism underneath that shift has still not been fully exposed. The mechanism starts with something Western policymakers spent years dismissing as inefficient: coordination, not central planning in the old Soviet sense. China is not operating a command economy where bureaucrats decide how many shoes get manufactured in Chongqing next quarter. The structure is stranger than that, more adaptive. Provincial governments compete with each other. State banks absorb strategic risk private lenders avoid. Ministries set directional priorities without always controlling execution. Companies fail constantly. Others scale at speeds that look abnormal from the outside because the infrastructure underneath them was prepared years earlier. Which means the patent story was never isolated from the factory story. Take China's Ministry of Industry and Information Technology. In 2015, Beijing launched Made in China 2025, a policy framework Western media mostly reduced to headlines about industrial ambition. The important detail sat deeper in the document. China identified 10 sectors where domestic firms needed to control high-value components rather than remain dependent on foreign suppliers. Robotics, aerospace systems, power equipment, advanced rail, agricultural machinery, biopharma, semiconductors. The list reads differently now than it did then. At the time, many American analysts viewed the targets as aspirational, a state brochure, a wish list attached to subsidies. But subsidies alone do not produce manufacturing density. Scale does. China's advantage came from stacking scale on top of iteration speed. A company manufacturing 1 million battery cells learns slower than a company manufacturing 100 million. Defect rates reveal themselves faster. Materials chemistry evolves faster. Engineers move between firms carrying tacit knowledge that never appears in academic papers. Then the refinements get patented. Small improvements, narrow claims. Thermal tolerances shaved downward by fractions of a percentage point. Interface stability improvements measured in milliseconds. Tiny changes. Massive consequences. A modern electric vehicle battery contains thousands of process decisions invisible to consumers. Which coating method reduced heat buildup? Which separator material survived stress testing longer? Which charging sequence preserved cycle life during winter temperatures? Every solved problem becomes defensible intellectual property. Eventually, competitors face a wall made not from one breakthrough, but from 10,000 refinements accumulated over years of production. That is what much of the 5.5 million figure actually represents: accumulated industrial learning. Look at solar manufacturing. By 2010, Germany led global solar deployment while Chinese firms aggressively expanded wafer and panel production capacity. Western companies often retained stronger research reputations, yet Chinese firms kept driving manufacturing costs downward through production scale and process optimization. Between 2011 and 2023, solar module prices collapsed by roughly 90%. Consumers benefited. Western manufacturers disappeared. Europe helped finance its own dependency transition in real time, and patents followed the factories. LONGi Green Energy, Trina Solar, and Tongwei built extensive intellectual property portfolios around wafer slicing, passivation technologies, and cell efficiency improvements. Much of this sounded deeply boring until energy prices surged after Russia's invasion of Ukraine. Suddenly, industrial capacity nobody cared about became geopolitically decisive. The same pattern emerged in drones. DJI controls roughly 70% of the global commercial drone market. That statistic sounds like a consumer electronics story, until you notice where DJI systems appear. Agriculture, infrastructure inspection, emergency response, mapping, construction, logistics. A modern economy increasingly sees itself through drones, which means the company controlling low-cost aerial imaging platforms accumulates extraordinary quantities of operational data and manufacturing experience simultaneously. American competitors struggled partly because venture capital seeks different timelines than industrial scale requires. Software startups can scale globally with relatively little physical infrastructure. Advanced manufacturing cannot. Factories are slower, margins arrive later, investors become impatient. China's state-linked financing structure tolerated that delay because Beijing viewed technological dependency as a national vulnerability rather than an unfortunate market outcome. Different incentive structure, different patience threshold. There is also something uncomfortable here for the United States specifically. America's innovation culture became heavily financialized. Firms learned that intellectual property itself could function as an asset class detached from manufacturing. Patent portfolios increased valuations. Licensing revenue mattered. Stock buybacks mattered more. During the same period, China increasingly treated patents as operational extensions of industrial policy. One side optimized ownership claims, the other optimized production ecosystems around those claims. And before anyone says this means China has already surpassed the United States technologically across the board, no. That argument collapses quickly under scrutiny. American firms still dominate crucial layers of advanced semiconductor design, aerospace engineering, pharmaceutical innovation, operating systems, and frontier AI research infrastructure. NVIDIA alone occupies a position in advanced AI compute that Beijing still cannot replicate domestically at equivalent scale. That counterargument deserves full weight because it is serious. Many Chinese patents are narrow and defensive rather than transformative. Patent quantity does not automatically equal technological leadership. Japan accumulated enormous patent volumes during the 1980s without permanently overtaking the American economy. Even today, China depends heavily on foreign semiconductor equipment from ASML in the Netherlands, Synopsys software from the United States, and high-end chip architecture originating outside its borders. There is a case, a strong one, that China's patent mountain exaggerates its actual technological independence. And there is another layer beneath that argument which changes the picture again. Because the most important technologies are often not the ones with the highest margins. They are the ones nobody can function without. Back to that 2018 export control memo. At the time, most coverage focused on artificial intelligence and quantum computing, because those phrases generated headlines cleanly. Venture capital understood them. Cable television understood them. Senators could say them into microphones without sounding confused. But buried deeper in the Commerce Department framework were references to gallium nitride power semiconductors, advanced lithography interfaces, and high-bandwidth memory packaging technologies. The document was not predicting where China already was. It was revealing what Washington feared China would eventually be capable of controlling. That distinction matters. Because the strongest counterargument from Part 2, that Chinese patents are inflated, commercially weak, and strategically overstated, begins to fracture when you compare those 2018 concerns against what happened afterward. Not across every technology sector, across infrastructure technologies specifically. The quiet layers underneath the visible products. Gallium nitride is a good example. Most consumers will never hear the term unless they accidentally read the fine print on a fast charger. Yet gallium nitride semiconductors matter because they allow power systems to run smaller, cooler, and more efficiently. Data centers use them. Electric vehicles increasingly rely on them. Military radar systems depend on them. Fifth-generation telecom infrastructure uses them. Which means whoever scales production and process expertise around gallium nitride controls efficiency improvements across multiple industries simultaneously. By 2024, Chinese institutions and firms accounted for a dominant share of global patent filings tied to gallium nitride manufacturing and applications. Not because Beijing woke up one morning wanting better phone chargers, because China spent years integrating material science, refinery capacity, university research funding, and manufacturing throughput into the same industrial cycle. The patents came last. That is the reversal. Western commentary often treats patents as evidence of innovation. In China's case, many patents were evidence that industrial dominance had already happened underneath the surface. The filings were the legal residue left behind by scale, and scale changes what dependency means. ASML in the Netherlands still leads the world in extreme ultraviolet lithography systems. No serious analyst disputes that. NVIDIA still dominates advanced AI accelerator design. Taiwan Semiconductor Manufacturing Company still operates fabrication capabilities China cannot yet fully reproduce domestically at the cutting edge. Those are real constraints, expensive ones, strategically painful ones. But the conversation shifts once you ask a different question. How many industries can function without Chinese manufacturing depth, even if they possess superior Western technology? Suddenly, the balance looks less comfortable. The International Energy Agency estimated in 2023 that China controlled over 80% of several stages of solar manufacturing capacity and battery material processing. More importantly, Chinese firms often occupied the least replaceable portions of the chain: refining, processing, precursor chemicals, industrial scaling. The boring sections, the chemically messy sections, the low-margin stages Western firms outsourced because returns looked unattractive 20 years ago. Now those stages determine whether supply chains move at all. I have gone back and forth on this. The conclusion I keep landing on is that the West misunderstood what technological leverage would look like in the 21st century. It assumed leverage would belong primarily to whoever designed the most advanced node, wrote the cleanest software, or owned the highest margin intellectual property. China built leverage lower in the stack: inside processing infrastructure, inside scaling capacity, inside manufacturing ecosystems dense enough to absorb sanctions and keep moving. Different philosophy, harder to disrupt. Huawei illustrates the point brutally well. After the 2019 sanctions, American officials expected isolation from advanced semiconductor supply chains to degrade Huawei permanently. And in smartphones, for a period, it did. Global market share collapsed. But then Huawei re-emerged through sectors less visible to Western consumers: industrial systems, cloud infrastructure, telecom hardware, energy management technologies. Areas where manufacturing integration mattered more than brand prestige. The company adapted because the surrounding ecosystem adapted with it, which is not the same thing as saying sanctions failed entirely. They slowed Chinese access to frontier chips. They raised costs. They forced redesigns. But slowing a system is different from reversing it, especially when that system already controls large portions of the industrial substrate beneath modern technology. There is another uncomfortable detail here. China's patent rise increasingly affects ordinary people who will never think about patent law. If Chinese battery firms control key processing technologies, EV prices elsewhere become partially dependent on Chinese licensing structures and supply stability. If Chinese grid equipment firms dominate transformer production, infrastructure costs in Europe and North America become exposed to Chinese manufacturing conditions. If drone components, solar wafers, or industrial robotics increasingly route through Chinese patent ecosystems, inflation itself begins inheriting geopolitical characteristics. A delayed shipment in Shenzhen can echo into utility bills in Berlin. And that changes the political meaning of technology. For years, American policymakers treated manufacturing dependency as an economic issue, while treating technological leadership as a separate innovation issue. China fused the two together. That fusion is the real story behind the 5.5 million patents. Not invention alone, control. My honest take: the numbers do not point where most headlines point. The important signal is not that China suddenly became more creative than everybody else. Human talent is widely distributed. The signal is that China built systems capable of converting industrial repetition into technological ownership faster than its rivals expected. Factories became research engines. Supply chains became patent engines. And by the time much of the West recognized the pattern, the legal architecture around future production had already thickened. Which leaves one final question. What happens when countries realize too late that the technologies they outsourced were the ones civilization quietly runs on? That final question lands differently once you stop thinking about patents as pieces of paper and start thinking about them as toll booths. Not every patent matters. Most do not. Many expire unused. Others exist purely for litigation leverage or accounting optics. But when patent ownership concentrates inside sectors that economies cannot easily function without, the patents become secondary evidence of something larger: accumulated industrial gravity. The kind that changes trade flows, reshapes alliances, and quietly limits political options long before leaders admit it publicly. That is where this story ends, and where the next one begins. The United States still possesses enormous advantages: frontier semiconductor design, elite research universities, aerospace engineering depth, venture capital networks capable of financing entirely new industries almost overnight. American firms remain dominant across critical layers of artificial intelligence infrastructure and advanced software systems. None of that disappears because China filed millions of patents. But dominance at the frontier does not automatically protect the foundation underneath it. Rome produced brilliant architecture while relying on grain routes it eventually struggled to secure. Britain controlled global finance while watching industrial competitors absorb manufacturing capacity. Empires often recognize strategic dependency only after a disruption reveals it physically. An empty shelf, a delayed shipment, a component nobody can source quickly enough. COVID exposed part of it. Energy shocks exposed another layer. Semiconductor shortages exposed more. The pattern kept repeating because the dependency was structural, not temporary. And structures move slowly until suddenly they do not. Look closely at what Washington has been doing since 2022. The CHIPS and Science Act allocated roughly $52 billion toward domestic semiconductor manufacturing incentives. The Inflation Reduction Act tied clean energy subsidies to North American sourcing requirements. The Department of Defense increased scrutiny around rare earth supply chains and battery sourcing. Europe launched its own industrial subsidy responses despite decades of free market orthodoxy. Governments do not spend hundreds of billions trying to rebuild capacity they believe remains secure. They spend because they finally understand the cost of losing it. The irony is difficult to ignore. For years, American corporate logic treated manufacturing relocation as efficiency. Build where labor is cheaper, optimize inventory, reduce redundancy, increase shareholder returns. Consumers enjoyed lower prices. Executives enjoyed rising equity valuations. Politicians enjoyed stable inflation numbers. Then the bill arrived. Rebuilding industrial ecosystems is brutally hard because ecosystems are not factories alone. They are supplier networks, engineering talent pools, machine tool expertise, chemical processing chains, logistics systems, financing structures, and tacit knowledge accumulated through repetition. A semiconductor plant without experienced upstream suppliers is like an airport without air traffic control. The building exists, the system does not. China understood that earlier than most Western governments did, which explains why the patent count matters less as innovation theater and more as evidence of sustained industrial concentration. 5.5 million active patents means China increasingly occupies the legal and operational layers surrounding future manufacturing. Electric grids, battery chemistry, industrial robotics, telecommunications hardware, power electronics, materials processing. Not every sector equally, not every lead permanent, but enough to shape pricing power and supply resilience globally. Enough to force strategic adaptation. My read on this, and I will attach my name to it, is that the next decade will not primarily be a contest over who invents the single most advanced technology. It will be a contest over who controls the widest industrial base capable of absorbing shocks while continuing to produce at scale. Different competition, different winners. And that shifts daily life in ways people will feel long before they understand them analytically. Electric vehicles may become cheaper partly because Chinese firms compressed battery production costs faster than competitors could match. Energy infrastructure projects in Europe and the United States may increasingly depend on Chinese-made transformers and grid components because domestic capacity remains insufficient. Consumer electronics prices, shipping timelines, electricity costs, even defense procurement schedules begin inheriting geopolitical friction from industrial dependencies built over 20 years. Ordinary life starts carrying invisible supply chain fingerprints. There is also a psychological layer here Western institutions still resist. Much of the post-Cold War economic order assumed manufacturing sophistication would naturally migrate toward liberal democracies over time, because innovation supposedly preferred decentralized systems. China complicated that assumption without fully replacing it. The result is ideological confusion. Beijing succeeded using a hybrid structure many economists once considered internally contradictory. State direction, private competition, industrial overcapacity, global export integration, tight political control, messy system, effective system. Sometimes the dry humor writes itself. Wall Street spent years insisting heavy manufacturing was yesterday's economy, while desperately waiting for shipments from Shenzhen to keep today's economy functioning. Now go back to the opening question. Why did that obscure 2018 Commerce Department memo mention gallium nitride, advanced lithography interfaces, and high-bandwidth memory packaging years before most people paid attention to them? Because parts of the American state already understood the risk, quietly, early enough to recognize it, too late to prevent all of it. The memo was not forecasting Chinese ambition. It was documenting American recognition that the industrial center of gravity had already started moving. And once gravity shifts, everything built around it eventually has to move too. Find a flaw in this argument. Seriously, I want to see it.